This case study was actually done at the Onset facility here in Bourne, Massachusetts, which is on Cape Cod. So we're in our Google Earth image here, and we're going to search on our location to show you exactly where that's located. So in our search bar up top, up in the upper left-hand corner, we've typed in our address, which is 470 MacArthur Boulevard, and we're going to search, and we will show you exactly where we are located. We're just over the Bourne Bridge on Cape Cod here, very close to Buzzards Bay. So there's our facility. You can see it's a L-shaped facility, and let's get in for a closer look, and we'll have a look at that. Here's our facility, made up of two buildings connected in an L configuration. You see all our solar panels up there on the roof as well. And where we're going to be monitoring is in the sprinkler rooms that are located in that L-shaped area. And I have an image with there's an arrow that shows you approximately where those are located. There are two rooms. Here's a doorway to one of those rooms. They were originally unheated spaces, but there are electric space heaters in there now that are thermostatically controlled. There's been some concern about monitoring in there in case the heaters fail. We didn't have any solution for that. It was going to cost a lot of money to get this tied into our existing alarm system, so we decided to put in our own products. Inside the room, you can see here there's a sprinkler configuration. This is a wet pipe type sprinkler setup, and we're going to be monitoring the temperature in here as well as the relative humidity, and we're going to monitor that AC voltage to get so we can get notified if the power goes out. The wiring configuration of this hardware is as follows. We used a RX3000 003, which is the 3G station. We wanted to use something that was independent of the building infrastructure in case the power went out. So this device is a standalone. It has that 3G modem in it, and it will be able to communicate even if the power goes out and send us our alarms. We have an STHB temperature and relative humidity sensor attached. The voltage monitoring circuit, we put in an external enclosure. This is the size enclosure you would typically use. We use the smaller one because of the space constraints, but this would either one would work for this application. So this is we used the potential transformer, the SPT150, to monitor the voltage. That was connected to a line cord. Of course, you want to be wiring this per local electrical code. This is in an enclosure, so it's protected, and we have that plugged into the outlet that's near this device. We're also using the FlexSmart TRMS module, that the smart module that will take the output of that potential transformer and monitor it and allow it to be monitored by that RX3000. And it's in the S-Adapt 6 external housing. Our configuration, we used a smaller housing just because of space constraints. Here's a photograph of the actual installation. You can see the RX3000 on top, the small enclosure underneath that. Here's a little zoomed in shot of that small enclosure, and now what I'd like to do is show you that HOBO link configuration of how we set up the alarm so we can be notified if there's a problem. Here we have the HOBO link page for this monitoring system, where we're monitoring temperature, relative humidity, and that AC voltage. In order to use that AC voltage measurement, we need to scale the input to that TRMS module. So here's my AC voltage channel right here. See, it's reading about 121 volts AC. We're in the US, so we expect it to be around 120. To get into the scaling for that, click on the little icon here, little tool screwdriver and wrench, and it will say configure this sensor. We'll click on that. We didn't give it a label, but we did scale it. and we put in a multiplier. The way we know what multiplier to use is we went into HOBO Link Help and we searched on scale factors for FlexSmart modules, and this is what we got. And basically these are all the different current transformers and potential transformers that we sell, and here are the multipliers. So we know this is an SP150. So this is what we want to use. We want to use our scaled units is volts AC, multiplier is this. We have a 0 offset, and the measurement type is voltage. So we can see here, scaled units, volts AC. So our multiplier, our offset, and our scale measurement type is AC voltage. So this is how we put in that scale factor. Okay, go back to this. What we did is we set up alarms so that our facilities people would be notified if there was a power outage or if the temperature got too cold in this room. The way you set up alarms with HOBO Link is you go up here to configure and click on alarm configuration. And you can see here are my two alarms, my two sensor alarms. The AC voltage, if it goes below 80 volts AC, we get notified. Also, if temperature goes below 35 degrees, we will get notified of that also. Here's an image from that alarm page. I didn't want to include the actual telephone number or email address of the person being notified. But basically what we're saying is that if our AC voltage goes below 80 volts AC for 3 log data points, we want to be notified. So that equates to 30 minutes on a 10-minute logging interval. And this person is going to get a text message and also an email. And we did the same thing with temperature, except we used 35 degrees Fahrenheit. And in closing, here's some historical data. This is a weekly view. The system's working very, very well for us. We've had it in place for about 7 months or so. We did get a notification on it one very late at night. There was an automobile accident and the power was interrupted, and our facilities people were so notified. So it's been working very, very well for us.